What's poppin', dogs? Mr. Allen here. We have ourselves a wonderful question about symmetry here. Is y equals 4 times x to the third power symmetric over the x-axis, over the y-axis, and over the origin? So let's start with the x-axis. Well, if it's symmetric over my x-axis, that means my same values need to appear both above and below that x-axis, meaning my y value is going to be changing sign. So what we're going to do is we're going to change that y to a negative y, and we're going to see if the equations are still equivalent. Well, if I do negative y equals 4x to the third, is that still going to be the same equation as the original? Well, no, because I'm going to have negative y equals 4x cubed, or you can have y equals negative 4x cubed. That is different than the OG. So, nope, it's out. X-axis symmetry does not exist for this particular function. Let's hop over to the y-axis. So for the y-axis, same kind of logic, but I'm going to be changing my x values from positive to negative and seeing if they match up on that graph or just within the equation here without actually graphing it. So I'm going to have y equals, and I'll have 4, and then parentheses, negative x cubed. Well, when I cube a negative, it retains its sign. Anything to the odd power, if it's negative going to the odd power, it's going to stay negative. If it's positive, it's going to stay positive. So here I've got y equals negative 4x cubed. All right. Not the same as the original. So, nope. So, we got nope here. And we've got, one sec, nope here. All right. Nope, nope. Wonder if it's going to be dope. Let's see here. That was dope. That was good. I like it. Okay. Origin. So, for origin, we need to change both my x and my y's to negative because it's going to reflect over both for origin symmetry. So, for this one, I'm going to have negative y equals 4, and then negative x cubed. So if I have negative y equals, and we know that this is going to be negative 4x cubed, what happens to my two negatives here? Well, they're going to cancel each other out. I'll be left with y equals 4x cubed. Is that the same as my original? You bet. And that's going to be, yep. Woo! So nope, nope. That's dope. I like it. That's awesome. Now, one last thing I want to talk about here is, with that y-axis, if this would have been, say, squared, or to the fourth, or to the sixth, some even power, would this have then become positive? It would. And if you think about the graph of, say, like a quadratic, it's a U shape. It is going to be symmetric over that y-axis, unless there's some kind of a shift involved. All right, so keep that in mind when you're looking for symmetry, but here's one dope example. Hope you guys enjoyed it.